All right, let's talk about something you've probably seen a million times if you've ever looked at a poll or a scientific study: the 95% confidence interval. It sounds pretty self-explanatory, right? Well, it turns out this is one of the single most misunderstood ideas in all of statistics. So today, we're going to clear it up once and for all.
So let's kick things off with a super classic example. Imagine you read a study that says the 95% confidence interval for how much the average student sleeps is somewhere between 7.5 and 8.5 hours a night. Simple enough. It gives us a nice, tidy range.
So your first thought, and look, it's what almost everyone thinks, is to say something just like this. Oh, okay, so there's a 95% chance that the real, true average sleep for all students is in that window. I mean, it just feels right, it sounds logical, but it's not.
To borrow a line from the great Inigo Montoya, that interpretation is completely, fundamentally wrong. And this isn't just some tiny, nitpicky detail for stats nerds. It's a massive misunderstanding of what a confidence interval is actually telling us.
So let's really dig into that common mistake. And hey, if you've made it before, don't feel bad, you are in very good company. Studies have shown this trips up just about everyone, from college students all the way up to experienced professional researchers.
Okay, so these two statements right here, they're the main offenders. They really seem to get the point across, but what they do is they put the probability on the wrong thing. And to see why that's such a big no-no in statistics, we need to get to the heart of the problem. The reason this is all so confusing is because of something that researchers have actually named: the fundamental confidence fallacy. This is the core mistake that sends our intuition off in the wrong direction. And here it is. The fallacy is confusing the success rate of the method you used with the probability that one single result from that method is correct. That 95%, it's about the procedure, not about the specific 7.5 to 8.5 hour interval you ended up with. To really get this, we have to think about what's moving and what's staying still. This is probably the best way to get your head around it. The true mean, the actual average sleep of every single student out there, it's like a fixed stationary target. We don't know exactly where it is, but it's not moving. Our confidence interval, though, that's like a net we throw at the target. And every time we grab a new sample of students, we throw a new net, and it lands in a slightly different place.
And this is the real kicker. Once you've done your calculation, once that net has landed, probability is out the window. Your specific interval from 7.5 to 8.5 hours either caught the true mean or it didn't. The probability is either 100% or it's 0%. We just don't know which it is. Okay, so we've torn down the wrong way of thinking. Now let's build up the right way, from the ground up. What does it actually mean? The secret is to imagine doing this whole thing over and over again. So you don't just do your sleep study once. Imagine you do it 100 times. Each time you get a new group of students and you calculate a slightly different confidence interval. The 95% tells you that if you did this again and again, about 95 of your 100 different intervals would successfully trap that true unknown average. This visual really helps it click. See that vertical dashed line? That's our true average. It's fixed. And all those little horizontal bars, those are all the different confidence intervals from our repeated attempts. As you can see, most of them crossed the line. They successfully captured the true value. But a few of them, just by pure random luck, missed it completely. So the confidence isn't in any one of those bars, it's in the method that made them. So that number, that 95%, that's what we call the confidence level. It's a measure of how good our procedure is over the long haul. It's the success rate of our net throwing technique, not the probability that any single throw is a hit. All right, now that we've nailed the main fallacy, let's quickly flag two other common traps that researchers have pointed out. This way you can avoid them too. First up is the precision fallacy. It's so tempting to see a really narrow interval and think, wow, we've really zeroed in on the answer. But not so fast. The width of the interval is just a feature of the math, and sometimes a really sloppy experiment can just randomly produce a very narrow interval that looks precise but isn't. And then there's the likelihood fallacy. This is the idea that the numbers inside the interval are the most likely or most reasonable possibilities for the true value. And again, nope. The theory just says it's a range that comes from a procedure with a certain long-term success rate. It doesn't actually tell us anything about which values are more likely than others. Okay, I know this has been a lot of theory, but
The good news is it all boils down to a super simple, practical tip that you can use every single time. Seriously, it's just about remembering one single word.
This is it. This is the magic key. Never, ever use the word chance or probability when you're talking about a confidence interval you've already calculated. Instead, you use the word confident. Saying we are 95% confident is the statistically correct way to phrase it.
Why does that one word make all the difference? Because when you say confident, what you're really doing is referring back to your faith in the procedure you used, a procedure that you know over the long run gets it right 95% of the time. It correctly puts the focus back on the reliability of the method, not on this one single result.
So let's wrap this all up. A 95% confidence interval is the output of a method that, if you were to repeat it endlessly, would catch the true value 95% of the time. It does not mean there's a 95% probability that your specific interval is one of the good ones. And the simple fix? Just always use the word confident.
It's a subtle difference, I know, but it's a hugely important one. And it really makes you think, doesn't it? If a concept this common is so widely misunderstood, even by the experts, what other statistical claims that we see every day deserve a second, more skeptical look? It's a great reminder to always ask what the numbers are really saying. Thanks for joining me.